Hello there, welcome to CXC Math TV. Today we will be looking at circle theorem. Now in doing circle theorem, we're first going to be reviewing the properties of a circle. We must know these. Now the first part of a circle is known as its circumference. The circumference is just the total distance around a circle. Some people like to refer to it as the perimeter. So the distance around the circle is its circumference. Now, putting a little dot in the middle of the circle, that's known as the center of the circle. Now, any line that passes through any 2 points on the circle and passes through its center, that line is known as the diameter. So these two lines displayed right here are diameters of the circle. Now, the diameter doesn't have to be horizontal or vertical. It can also be slanted because guess why? It still passes through 2 points on the circumference and the center of the circle. So it is still a diameter. The next part of the circle is a chord. Now a chord is just any line that passes through 2 points on the circle. Alright, and so a chord is just a line touching the circumference of the circle at any 2 points. So therefore the diameter, it is a chord. It's just a special type of chord because it passes through the center of the circle. Then we have the radius. The radius is just a line from one point or a point on the circumference of the circle to its center. That's known as the radius. When we have two or more radius, we call it radii. Alright, the next thing to look at is this gray area right here. We put that in gray. Alright, you notice that there are two radii around it and the curved portion of the circle. That is known as the sector. A sector is a part of the circle between two radii and an arc. So as you see, we put the little red around. That part of the circumference is known as the arc, and an arc is just a part of the circumference at the edge of a sector. So we can divide the circle in this case into two sectors, the minor sector and the major sector. The smaller one is the minor, the bigger one is the major sector. We can also divide the circle into the minor arc, the small portion of the circumference right there, and the larger portion of the circumference as the major arc. Next thing is that we have is a segment. If we were to just draw a chord, then we see that the circle is divided into two, the yellow portion and the red portion. The red portion is the minor segment and the yellow portion is the major segment. So the segment is just a part of the circle between a chord and the arc. Now, if we were to just draw a line and that line touches the circle, in this case at the point P, just at one point. So if the line touches the circle just at one point, we call this line a tangent line. A tangent line just means that the line intersects the circle only at one point. So pause the video and just complete the two diagrams. You can copy it in your notebook and write down which part is what. I'm sure we'd have all gotten it correctly. Labeled on the screen right here, we have all the parts of the circle labeled in the two diagrams. Beautiful. Now that we've reviewed the part of the circles, now we can get started into the main topic for today, which is circle theorem. Now theorem number one. Theorem 1 is that the angle formed at the center of the circle is going to be 2 times the angle formed at the circumference of the circle when they're subtended or formed by a common chord. So let's put two radii on the diagram. So the angle at the center right there between the two radii is, let's call it 2 theta. That means that if there was two chords now connected from the same chord, so the angle at the circumference right there, theta, notice that we have theta there. It is half of what's the angle at the center because the angle at the center is 2 times the angle at the circumference when they're subtended by the same chord. Now we put that common chord there in blue. That's the common chord between the center angle and the angle at the circumference. So if we are to look at the following diagrams right here, we can see the angles at the center being 2x and the angle at the center being x. We also see the common chords being highlighted in red. Alright, so whenever we have the angle at the center, it's going to be 2 times the angle at the circumference when they are formed by a common chord. And in this case, the common chord all being in red. Now let's look at how we're going to utilize it in a question. Hey! So this question here, it says A, B, and C are 3 points on the circumference of a circle. O is the center of the circle. Angle AOB is 112 degrees. Work out the sides of angle ACB. Now angle ACB, that's the angle at the center. So the angle at the center is going to be a half of 112, which is 56 degrees. And then the theorem that we use, you always want to put the theorem after and tell them angle at the center is twice the size of the angle at the circumference when they're subtended by the same chord. So we have to give them the theorem that we use to find the angle. That's it. Nice. So we put on the 56 degrees on the diagram. And in light blue, we put on the common chord right there going from A to B. Just to show you right there, that's the chord where we can use this theorem. So pause the video and write down what's the value of Z. Now, if you wrote down 44 degrees, you're absolutely correct, all right? Because angle at the center is going to be 2 times the angle at the circumference. And we already see the common chord right there in the image being black. Lovely. Now, let's step it up a little bit right here. Question 3. A circle with center O has points ABC on the circumference and angle ABC is 20 degrees. Find the size of angle BAC. So pause the video and attempt this question. Now, remember, angle at the center is twice the size of the angle at the circumference. So the angle at O, that's a semicircle. So the angle at O is 180 degrees. So the angle at the circumference is going to be 90 degrees. So angle ACB is 90 degrees. Now once we know that angle ACB is 90, they told us angle ABC is 20. So put on that 20 degrees right there. And so angle BAC is going to be 180 minus 20 plus 90, which is 70 degrees, since angles in a triangle sum to 180. And so angle BAC is 70 degrees. Nice. So we see that we step up the level a little bit. Nice. Let's look at a couple more. So look at these two images right here, and I want you to find the unknown angles giving reasons for your answer. Alright, let's split it in two. As we look at this, the first image on the left, we need to find angle X. But we realize that AOB is going to be an isosceles triangle because AO is a radius and OB is a radius. So that angle right there is 42. And so therefore angles in a triangle sum to 180. So angle X is going to be 180 minus 2 times 42, which is 96 degrees. And then angle at the center is 2 times the angle at the circumference. So angle Y will be a half of 96 degrees, which is 48 degrees. Really nice. Easy. Let's go to the right now. Now looking at the right, we need to find angles P and angle Q. Now angle P is going to be 2 times 62 because angle at the center is twice the angle at the circumference. That's 124. Now angle Q. Again, AO and OB are both radii. And so we can say that angle Q is going to be 180 minus 124 over 2, which is 28 degrees because it's an isosceles triangle. So we know that the angle at A and the angle at B will both be 28 degrees. Nice. And that concludes theorem 1. Now, the second theorem is an extension of theorem 1. It says the angle in a semicircle is a right angle. And it really stems from theorem 1 because if you look at it, it's really angle at the center being 180 is twice the size of angle at the circumference being 90. And you can see the common chord, which in this case is the diameter of the circle. So in the diagram, O is the center of the circle. Write down the value of W. What will be W? As you rightfully would have said, more than likely, angle W is 90 degrees because angles in a semicircle is right angle. Alright, so theorem 3 says angles subtended by an arc or chord in the same segment are equal. Now we just want to put on the same chord in red. So you can see that chord right there in red. And that allows all of these angles right there to be equal. Now, if you really were to look at it, all of these are actually similar triangles. And so similar triangles, they have equal corresponding angles. But we'll get into that when we're doing geometric proofs of circle theory in another video. So, as you can see in the next diagram that appear right here, we can see that the y's right there, those two angles would be equal, and the x's right there, those would be equal as well, because angles subtended by an arc or chord in the same segment are going to be equal. So, find the unknown values in each case. Find angle x, angle y in the both diagrams. So as you pause and attempted, you should have clearly stated angle x is equal to angle y, which is 38 degrees. And we should have stated that angle x over here is 30 on the right and angle y is 40 degrees. Easy, easy, easy. Nice. Let's see how they'd apply it to a more challenging question. So pause and attempt this one. P, Q, R, S are 4 points on the circumference of a circle. PR meets QS at A. Angle PRS is 57 degrees and angle PAQ is 78 degrees. Work out the size of angle Y. Pause the video and attempt that question. Now, as we attempt this question right here, first thing is, if we were to just put on, let's just put on two lines right there for PR and QS. What do we notice? Those are two intersecting lines, so we can use vertically opposite angles to first get angle RAS. So the angle at A then is 78 degrees by vertically opposite angles. Then we can find angle RSA. Angle RSA is going to be 180 minus 78 plus 57. And that would be equal to 45. So we can put the angle at S being 45 degrees. Now once we get the angle at S to be 45 degrees, remember that angles subtended by an arc in the same segment are equal. And so Y is equal to 45 degrees. Alright, nice. Alright, theorem number 4. So look at this circle right here. And so we're given a, you see that we're given two radii, AO and OB, and we see tangents at A and B. Now, the angle between a tangent and a radius is 90 degrees. That's the theorem that we need to remember. Angle between a tangent and a radius is 90 degrees. That is because the tangent and the radius, they are perpendicular to each other. Alright, so that means that a radius and the tangent, they are always perpendicular to each other. So, let's use that theorem to find the values of x, y, and z in this diagram right here. So first we realize that angle y is 90 degrees because angles in a semicircle is 90. So now, once we get angle y, we know z is going to be 180 minus 30 plus 90, which is 60 degrees, because angles in a triangle sum to 180. So we can replace those two now, put the 90 and the 60 degrees in the diagram. And then we know that angle between the radius OT and the tangent AB is 90 degrees. So we put that on the diagram. And so therefore x is going to be equal to 180 minus 90 plus 36, which is 54. And so angle x is 54 degrees. And we can then put that on the diagram right there. Alright, so all three angles are there now in white. Easy.